Welcome to another set of science video notes. As always, you'll need highlighters to highlight keywords, definitions, and facts. You may create a key on the upper right-hand corner of your paper. You can always pause, rewind, and replay at any time during a video so that you can take your notes at your own pace. Alright, let's begin. On page OP52 of your science notebook, title this Velocity Time Graphs ECQs. There are 3 ECQ questions to write down, so please make sure you leave some space in between each one. Pause and write now if you need to. On page IP52, title it ECQ Answers. Stick a page tab on your ECQ page. Number 1 through 3, leaving space between for each answer. And you will answer the ECQs after the notes are completed. When you're ready, go ahead and continue on the video. Velocity Time Graphs is a title on page IP53. We'll be taking some Cornell notes. Okay. So make sure you write the title before you move on. If you look at this picture in the front, these are some old pictures from an old racing game called F-Zero, way back in the days on the Super Nintendo. Here's are some stats for the Fire Stingray and the Golden Fox. Look at these two pictures and decide which one do you think has a faster acceleration. Which one would you choose if you had to choose one for your game? The Fire Stingray, and this chart shows you its acceleration. Right? And remember, acceleration is a change in velocity over time. It's how fast an object can speed up, okay, or slow down and change direction. This is the Golden Fox over here. So take a look at this graph too and decide which one do you think is going to move faster, or actually speed up faster. If you chose the Fire Stingray, actually it takes a longer time to speed up to maximum speed, so it does not have a faster acceleration. The Golden Fox, however, speeds up like this, right, on the graph, so it has a faster acceleration. So if you want to drive faster, I would choose the Golden Fox. Alright, let's continue. Number 1, a velocity time graph is different from a distance time graph. There are at least 3 differences. The first one, A, states that a velocity time graph, or VT graph here, shows how fast an object can accelerate, which means it can change speed or direction. A distance time graph just shows you how fast it moves, right? Yep. B shows you that the y-axis on a velocity time graph is now speed, or velocity. In our old distance time graph, it was just distance. And C shows you that the slope represents acceleration in this case. Slope is still rise over run, but in this case, slope represents acceleration. In our old distance time graph, slope represented speed. Okay. This helps you with one of your ECQ questions, by the way. Pause and write if you need to. Number 2. The title is Velocity Time Graphs for this section, and you need to draw and label this in your notes. So make sure you make a graph that has velocity on the y-axis and time on the x-axis. When you draw your graph, you can highlight different sections if you like. Make sure you label where there is a positive acceleration, 0 acceleration, and negative acceleration. Go ahead and pause and draw this now. 2A, increasing velocity is found in section 1, where there's this red part right here. This is when the slope is positive, and that shows you positive acceleration. If you remember from our acceleration notes, positive acceleration means it's speeding up and going faster. So for example, here, you might be starting here at 0 meters per second, meaning your car is not moving. When you step on the gas pedal, it goes and speeds up, right? So it's speeding up. It's on our old graph, it was just a constant speed, but here it's going faster and faster and faster. Okay? All right, let's go to the next one. On 2B, constant velocity is section 2 right here where there is no slope. It's a flat line. This means zero acceleration, which means it's moving, but it's moving at a constant speed and direction. In our old graph, in a distance time graph, the flat line means it's not moving at all, right? But in this case, because it's a velocity time graph, it shows you there is speed, and so it's moving. 2C, decreasing velocity, is found in section 3. Here you have negative acceleration because there's a negative slope, and that means you're slowing down. So in the green section here, it's slowing down, slowing down, slowing down until it hits 0 meters per second, which means it's no longer moving. Okay. All right. And that's it. You're going to finish your Cornell notes by writing 3 to 4 questions on the left side of your notes. Remember, there are no what questions. You can refer to page IP6 of your notebook for question ideas like compare, contrast, explain, define, how, and so on. You cannot repeat any question words either, so keep that in mind. Your questions should be answered by those notes you took, and at the bottom, write a 3 to 4 sentence summary at the end. Number and highlight your periods when you finish. And that's it for our notes. They're very short and quick, but we will have some practice activities with graphs after this. Make sure your notes are signed off before you leave class so that you can get credit for your notes today when they're done. Thank you. That's it.